Section 7-8, Part 2. This part is not in your textbook. Okay, this textbook does not teach this method, but I find it a very useful method when it comes to factoring. We are going to factor trinomials using a method which I call organized factoring. Other places call it the AC method. Organized factoring or the AC method. Okay. All right, so if you remember back, we're going to jump back a little bit, section 7-6. Okay, when it came to factoring things with a leading coefficient that wasn't 1, so we had a leading coefficient that wasn't 1, really our only method was guessing and checking. Sometimes we caught it 2 in, sometimes we caught it right away, other times we had to do a few different tries, like we had to try 3, 4, sometimes 5, 6, 7 times to try to find one that works. Okay, so we're going to learn a new method now that we know how to factor by grouping. We're going to look at a new method that will always factor it. If it's factorable, this method will always work and it doesn't involve any guessing or checking. Okay, so the first thing we're going to do is we're going to just look at a very standard trinomial. If it's ax squared plus bx plus c. So again, this a, this b, and this c are just numbers. Normally this leading coefficient, you really only want to do this when the leading coefficient is not 1. Leading coefficient is not 1. Okay, so we're going to kind of break this down into some multiple steps. This is organized factoring. Okay, step 1. Okay, step 1, multiply A and C. Okay, hence why it's called the A to C method. We're going to multiply the leading coefficient times the constant. So multiply A and C. Leading coefficient times constant. Okay, so let's go ahead and let's do that in this problem down here. So we're going to multiply for step 1, multiply the leading coefficient times the constant. So we're going to multiply the 4 times the 3 and get 12. Okay, so that's step 1. Step 2. Okay, find 2 factors of A times C with a sum of B. Meaning, I want to look for 2 numbers that multiply to give me 12, that add to give me 13. The 13 comes from here, that middle term. So we want to list factors of 12. So we've got 1 and 12. Oh, I think we found it. 1 plus 12 is 13. Okay, 1 plus 12 is 13. Okay, step 3. So once you found that, step 3. Rewrite the middle term using these factors. So what I'm going to do now is I'm going to rewrite this middle term. This middle term is 13x. I'm going to rewrite it using the 1 and 12. So I'll have 1x plus 12x. Everything else on this stays the same. I'm still going to have 4x squared plus x plus 12x plus 3. Okay. Our very last step, step 4. It's now got 4 terms. Group it. Or factor it by grouping, just like we learned here. Rearrange if needed. You shouldn't have to rearrange. Just rearrange, group similar terms, factor out the greatest common factor. Because now what I've done, if you notice here, I have now rewritten, this had 3 terms. 4x squared is 1 term, a 13x and a 3. 3 terms. I've now rewritten it as an equivalent polynomial. These are the same thing. If I put together like terms, I get the same thing. If I add the x plus 12x, I get 13x. But now what it's done is it's made it 4 terms. 4x squared plus x plus 12x plus 3. Now that it's 4 terms, I can factor it by grouping. I'm going to group these first two, 4x squared plus x plus 12x plus 3. Now, if you remember from the previous section, we're going to go ahead and factor out our common factors. So out of these two, they both have an x, so I can factor an x out. I'll be left with 4 times x plus, I'm going to need a 1. So when I distribute this in, that's 4x to the second plus x. That gets me back to here. Plus, out of these two common factors, so they both don't have an x. But 3 goes into both of those, so we'll factor out a 3. 3 times 4 gets me the 12, then the x, plus, again, I need that 1. 4x plus 1. So now ask myself, if I distribute this back in, will I get back to here? Yes, I will. So these two are equivalent, meaning they're equal. And these two are equivalent. And these two are equivalent. I'm just replacing this is the same as that, is the same as that, is the same as that. You want to make sure you're equivalent as you work your way down. Now, in the last section, if you notice, these two terms, we really have two terms here. We've got this guy plus this guy. They both have a 4x plus 1. So I'm going to write that as 1 time, 4x plus 1 out front. We're factoring out the greatest common factor, times, we need an x, plus 3. Plus 3 comes from there. So if I multiply 4x times 1 times x plus 3, I should get back to where I started. If not sure, we always want to check it, make sure. So let's distribute this out. We get 4x to the second plus 12x plus 1x plus 3, 4x squared, 12x plus 1x is 13x plus 3. Yep, it worked. Got me back to where I started, to that guy right there. Okay. All right, so there is my factored 4x plus 1, x plus 3. Again, this is using a method called organized factoring. Okay, next one. Step 1, again, multiply the a and the c. The a is 3, the c is 2. 3 times 2 is 6. Next, I want to find two factors of this 6 that add to get me negative 7. I want to get a negative 7 when I add them. Well, negative 1 and negative 6 should do it. When I multiply negative 1 and negative 6, I get positive 6. When I add them, I get negative 7. Next, rewrite the middle term using those. So negative 1x, so I'm going to have negative x. I'm going to write this as plus negative 6x. So we have 3x squared minus x, or again, we could just write plus negative 1x plus negative 6x plus 2. This now has 4 terms, so I can factor it by grouping. 4 terms. We've got 3x squared plus negative x. Again, double checking to make sure this is equivalent to that one. It is. When I put these two together, I get negative 7. Now I'm going to group the first two, 3x squared and the negative x, plus negative 6x plus the 2. Okay, now factor out common factors. Out of these two, they both have an x in common, so we'll take the x out. 3x minus 1 plus, out of these two, well, we don't like leading coefficients here to be negative. So I'm going to take out a negative 2. They both have a 2 in common. Negative 2 times positive 3x gets me that negative 6x if I distribute that in. And negative 2 times negative 1 gets me that positive 2. Okay, again, now I have my two factors. I've got this guy plus this guy. They both have a 3x plus 1 in common. So I'll write 3x plus 1. Oh, minus 1. And then 3x minus 1 times x plus a negative 2. It's the same as minus 2. So 3x minus 1 and x minus 2. Again, let's check it, make sure it works. Multiply it out, distribute. 3x times x is 3x to the second. 3x times negative 2 is negative 6x. Negative 1 times x, negative x plus 2. Yep, 3x squared minus 7x plus 2. Got her. It worked. So there we are, factored. Okay, we're going to go ahead and do one more. All right, again, step 1, multiply the a and the c. A is 2, c is negative. First thing, I'm going to rewrite these as negative. Plus a negative 7, and a negative 5. 2 times negative 7 is negative 14. I want to multiply it again, negative 14. So step 2, and add to get negative 5. I want to add to get negative 5. So let's do 1 and 14. If the 1's negative, well, if the 14's negative, that would give me negative 13. Nope, that won't work. 2 and 7. If the 7's negative, it works. 2 times negative 7 is negative 14. 2 plus negative 7 is negative 5. We found it. Step 3, rewrite the middle term using those factors. So I'm going to rewrite that negative 5 as using the 2 and the 7. So instead of negative 5, we'll have positive 2x plus a negative 7. And then everything else stays the same. We'll have 2x squared and then plus a negative 7. Again, I'm attaching the negatives onto the numbers to prevent that confusion. Now we've got 4 terms. Again, making sure this one is equivalent to the one above it. We've got 4 terms, so let's group. 2x to the second plus 2x plus negative 7x plus a negative 7. Well, out of these first 2, they both have a 2, they both have an x. Let's factor out a 2x. 2x times, we'll need 1x to get to 2x squared plus 1. Plus, now both of these have a negative and a negative 7, so I can take that negative 7 out, and I'd be left with x plus 1. If I distribute that back in, we'd get negative 7x squared plus a negative 7. Now again, we have now factor by grouping. We have our 2 terms, this guy and this guy. They both have an x plus 1. So we'll factor out that x plus 1. And then we're left with a 2x plus a negative 7, 2x minus 7. And let's check it, make sure it worked. Okay, x times 2x, 2x to the second. X times negative 7 is an x. 1 times 2x, positive 2x. 1 times negative 7, negative 7. Put together like terms. It worked. Yay! All done. There we are, factored. Okay, now for your practice, I want you to do these 12 problems down here. Do not guess and check. I want you to do them using organized factoring. And if you notice, their leading coefficients are all a number other than 2, other than 1, sorry. But always first check for, give you a hint, check for greatest common factor. On many of these, you can factor out a greatest common factor. For example, this first one, 6, 12, and 18 are all multiples of 6. Factor out a 6 first. 5, 15, 50, all multiples of 5. Factor out a 5. 9, 36, 27. Factor out a 9 first. That's always a good first step. Not all of them can do that. For example, here, 4, 21, and 18, those all don't have the same factors. The only factors of 21 are, 3 and 7, and those aren't factors of the other ones. So it doesn't always work, but it's always a good bet. And when you have a leading coefficient that's negative, factor that negative out first. Okay, good luck, and come see me if you need help.